Physicists just pulled energy from what we thought was nothing for centuries. The idea of nothingness has fascinated philosophers and scientists alike. Empty space was long imagined as a void, a silent backdrop against which the drama of the universe unfolds, but modern physics has steadily chipped away at that notion, revealing that emptiness is far from empty. Now, in a groundbreaking experiment, physicists have managed to extract real, usable energy from what appears to be a complete vacuum. This achievement, rooted in the strange rules of quantum mechanics, could reshape our understanding of the universe and open doors to technologies once confined to science fiction. The quantum vacuum, a seething sea of fluctuations. At first glance, a vacuum seems like the ultimate absence. No particles, no light, no matter. Yet quantum theory insists that even in such emptiness, energy is never truly zero. Thanks to the uncertainty principle, particles and antiparticles constantly flicker in and out of existence, borrowing energy from the void before vanishing again. These quantum fluctuations mean that space itself is alive with invisible potential. Physicists call this phenomenon quantum vacuum energy, and it has been theorized for decades. What makes the recent experiment revolutionary is that scientists have now learned how to reach in and grab it. From theory to reality, the concept of vacuum energy is not new. It underpins ideas like the Casimir effect, where two metal plates placed close together in a vacuum experience a mysterious force due to fluctuations in the quantum field. It also plays a role in cosmology, where vacuum energy is linked to the accelerating expansion of the universe. But until now, these effects were largely theoretical curiosities or indirect observations. The latest experiment demonstrates that vacuum energy can be harnessed in a controlled, measurable way, transforming it from abstract speculation into tangible reality. How did they do it? The details are complex, but the principle is elegant. By carefully manipulating quantum fields, researchers created conditions where energy could be drawn out of the vacuum without violating conservation laws. Think of it as tapping into the restless fluctuations of empty space, coaxing them into producing a usable output. While the amount of energy extracted is small, the implications are enormous. It proves that the vacuum is not a barren desert, but a dynamic reservoir waiting to be explored. Why this matters? The ability to harvest energy from nothing challenges our deepest assumptions about physics. It suggests that the universe is far more resourceful than we imagined. If vacuum energy can be scaled up, it could revolutionize power systems, offering a source that is clean, inexhaustible, and fundamentally different from anything we use today. Imagine spacecraft powered not by fuel tanks, but by the fabric of space itself. Imagine cities drawing electricity from the quantum fluctuations that permeate every corner of the cosmos. While such visions remain speculative, the door has been cracked open. Beyond technology, a shift in perspective equally profound is the philosophical impact. For centuries, nothing was treated as an absolute void beyond comprehension. Quantum mechanics now tells us that nothingness is an illusion. The vacuum hums with activity, a hidden orchestra playing beneath the silence. This realization forces us to rethink the nature of reality. If energy exists in emptiness, what else might be lurking in the shadows of the quantum world? Could other phenomena, dismissed as impossible, be waiting to be discovered? Challenges ahead, of course. Enormous hurdles remain. Extracting vacuum energy in significant quantities will require breakthroughs in materials science, quantum control, and engineering. There are also questions about safety and stability. Tapping into the quantum vacuum is not like flipping a switch on a generator. The physics is delicate, and unintended consequences must be carefully studied. Yet history shows that today's impossibilities often become tomorrow's technologies. Nuclear power, lasers, and semiconductors all began as strange theoretical ideas before transforming society. A glimpse of the future. The experiment marks a turning point. It demonstrates that the boundary between science fiction and science fact is thinner than we think. Quantum vacuum energy may one day power spacecraft, reshape global energy systems, or illuminate mysteries of cosmology. More immediately, it reminds us that the universe is richer and stranger than our intuitions allow. Empty space is not empty. Nothingness is not nothing. And in that paradox lies the promise of discovery.